in from Seattle. We got a couple of people from India, Sandeep.
Okay, I think we're all set up. We're live on LinkedIn and YouTube. Hi, everyone.
Can you send me the links for those?
Yep. Let me just grab these links to Jules, my co-host, and then we'll go ahead and get started. Hi, everyone. Oh, let me mute that. Okay, 1 second. Okay, there's the LinkedIn URL, Jules, and then let me just get the YouTube link for you. All right, I think we're good. I think we're all set up. Both live streams look good. So let's go ahead and get started here. I'm going to share my screen. Good morning, Steve. All right, share screen. All right, let's get started here. Hi, everyone. Thanks for joining us. We're excited. We have two really awesome speakers here. We're going to be speaking about MLflow integrations with PyCaret and PyTorch. So we have Moez, who's the founder and author of PyCaret, and Geeta, who's a partner engineering head at Facebook AI. And a quick call out to our Data Plus AI online meetup group. So this is one of our tech talks that we host on our online meetup group. We run them live and stream to YouTube and LinkedIn. So welcome everyone from joining us in those spaces. So I'd invite you to join our meetup group so you can be notified of our upcoming sessions and all the awesome sessions we have coming up. And I also invite you to subscribe to our YouTube channel, turn on notifications. We host all of our video recordings there. So each of our sessions are recorded and they're hosted there. So we have a Data Plus AI online meetup group playlist, and we also do kind of playlists for different series that we run. And then follow us on LinkedIn too. We're live there as well. So our next meetup, we actually have another one. It's the fourth in a 4-part series with Salesforce Engineering, and that's this Thursday. So I invite you to check that session out. I'd love for you to join us. We also have a playlist. So we have the 3 video recordings of the first 3 sessions available on YouTube. So I'll send that link in all the chats so you can check it out. And then we're super excited. We have our summit coming up. I know I think we've done polls here and there, and I know a lot of the folks joining us are new. So I always like to plug our summit. We're super excited about it coming up. That's going to be May 24th through the 28th. We have some really awesome speakers, keynote speakers, Moez Ali, Renaud, Matei. Super excited. It's tons of content, over 200 sessions. We have also training the first 2 days. So lots of good stuff in there, sessions for everyone, beginner through advanced levels, and a variety of topics. So I hope you'll register, and hopefully we'll see you there end of May. And just a quick moment before I pass it to my co-host, Jules, just a reminder, this is recorded, and I'll send the link in all the chat spaces so you can review it at a later date if you'd like. And then also, please ask questions. So YouTube and LinkedIn, put your questions in the chat. We'll gather those, and we'll have time after each session for questions. And then if you're on Zoom, it would be great if you could post those in the Q&A. So without further ado, let's pass it over to Jules.
Well, thank you, Karen. Let me see if I can share my screen over here. Lovely. Okay, can you guys see my presentation?
Yep, looks good.
Well, welcome all of you to our second part in the series of MLflow plus integration in community. And one of the reasons we really want to do this is to really acknowledge and recognize and amplify some of the integrations and some of the very valuable community contributions that we actually have from the MLflow community. And so today, if you are not familiar with, if you actually are using PyTorch, if you're using MLflow, straight out of the box, these are some of the integrations and some of the built-in support that we actually have in MLflow right away. And today you're going to hear about the valuable contributions from PyCaret, how you can actually use PyCaret with MLflow, as well as the ongoing contributions that Facebook's AI team and PyTorch engineering team has actually made. So we are actually quite excited to hear about them. And the community is actually growing rapidly, almost on a daily basis. We have organizations who are actually using MLflow in production. These are the organizations that you can actually see some notable names over here who are contributing to the MLflow, which is actually extending its adoption quite a bit. And we have close to about 90 organizations who are using it, and a number of them are contributing significantly. So if you are using MLflow in production, if you're using it at scale, we want to hear about it and let me know so I can actually include your logo in there. Now, the contributions over the period of 3 years have sort of ranged in number of areas in MLflow. The most important ones are some of the deployment plugins that are very common. Last week, we actually heard from the Azure ML people who actually contributed the thin client, as well as how they can do experimentation using ML Azure. We also heard from Algorithmia, whereby the plugin allows you to log all your models in MLflow and then deploy them into the target environment. Redis AI is another one that actually has contributed a plugin that allows you to do your MLflow logging and tracking experiment on your particular host and then deploy the models for inference on the Redis API. And then MLflow Ray Serve is the newest plugin contribution from the community, whereby you can actually run your deployed models on Ray Serve. And then PyTorch Torch Serve is another one. There are other plugins areas where you can actually have your MLflow project, for example, run on a remote machine with MLflow Yarn. And if you want to use a different tracking store other than the one that we actually provide, Elastic Store is another plugin that actually has been contributed. So you can see this actually extend how MLflow can actually be used with other ML ecosystem as well. So this is actually quite important for us to actually have the community contribution as well. And then, there are more and more plugins which are being contributed from the community. The SQL Server, if you actually want to use your backend store other than what we are using by default, you can use the DB store. If you want to use an artifact store for Alibaba to store your artifacts and models, you can actually use that. And there are miscellaneous contributions all from the community. The Windows, Microsoft actually provided a huge Windows support for them. The MLflow thin client, which you actually saw a demonstration last week, gives you the ability to actually work in just the client itself that reduces the binary of MLflow and works very well with the Azure ML. R Studio, for example, is the one that actually provided all the R integration with the MLflow. This has actually really been a huge, and then needless to say, PyTorch integrations are continuing to extend the functionality that you can actually use with MLflow. Bug fixes, documentation, code snippets, all these are coming from the community. And so if you're interested, put your integration and we'll be more than happy to look at your PR. And so I'm really looking forward for your contribution as well to extend the MLflow to a larger community. And if you look at over the board, these are all the contributions which are actually happening on monthly basis. There are some spikes now and then because of the releases every 6 or 8 weeks. So we actually are quite excited to see that. And in the last 4 months, we have actually seen over 4 million downloads, and these are the downloads which are actually happening. So there is ample of interest in the community, and people are really excited to use MLflow in whatever capacity they have. And then obviously no open source project or no open source community is without some vanity stats. So I'm going to share some of the vanity stats with you. Since the release of MLflow, we have had over 2K forks, about 8.9 stars, K stars, 86 releases. Yesterday we released 1.6. and we are at about 295 contributors. So I want one of you guys to be the 300 contributor in the coming days or weeks. And last night we released 1.6 that has some big rocks that were part of the release. One is for you the ability to use PySpark ML estimators with autolog, so you don't have to worry about explicitly logging any of the MLflow entities. It does all automatically for you. We have added cat boost as another MLflow flavor, and some bug fixes here and there and enhancements. So if you want to get involved, and I'm looking forward to hear from you, go to mlflow.org, join our community, join the user group, join the Slack channel, and file your issues and file your PR. And I'm the one who's actually handling all the triages and the issues. So I'm looking forward to that. With that, I'm going to now introduce our first speaker. It's really a pleasure for me to actually have Moez, who is the original creator of PyCaret, and he's going to talk about how you actually use PyCaret with MLflow today. He's a seasoned data scientist and original creator of PyCaret. So Moez, take it away. It's all yours.
Thank you. Can you hear me okay?
Yes, we can.
All right. A really great introduction, Jules. I'm very excited to see the progress MLflow has made in last few years. It's amazing. Okay, you see the presentation on my screen? Okay, great.
Yes, we do.
All right. Hello, thank you everyone for joining me here today. I'll quickly introduce myself. I'm a data scientist with background in finance and economics. I have 10 years of experience, mostly working with data and solving problems. I have worked for healthcare, education, consulting, and fintech institutions. I'm a chartered accountant by profession, so I'm a member of CPA, CMA, ACMA, CGMA, and I have in last 6-7 years, I have changed 4 different continents, and I've worked in 4 different countries in 4 different continents. And these days I'm based in Toronto, Canada. So, and I have a couple of links here for my profiles. I have a LinkedIn, very active LinkedIn user, Twitter, and Medium. I'm a very active blog writer. I write 4 to 5 blogs each week, and my blogs and tutorials are mostly focused around beginners who are just getting into data science without computer science background. Bunch of important links here. The most important link is this one, github.com/PyCaret/PyCaret-demo-MLflow. If somebody can please write this link on chat. So this is the repo where this presentation, as well as all the demos that we are going to see today, they are uploaded there. And there are a bunch of links in this presentation that are useful. So, so you can get them later. We have a Slack community. We have very active community that basically handles questions and triaging on GitHub. But if you are doing something, stuck in a problem, Slack channel is the fastest way to get the answer to your queries. I personally am active on Slack channel at least for an hour a day to respond to the questions. You would find a bunch of resources for PyCaret, and this presentation has a lot of links. So these images are links, and there are a lot of integrations of PyCaret with tools like Gradio, FastAI, AWS, Azure, MLflow, GCP. I'm gonna skip the slides. They're there just for you to watch them later. Okay. Let's get started. So what you see here is a very high level machine learning lifecycle. It's a workflow. It starts with a business problem, goes to data sourcing and ETL. So this would include things like sourcing the data from your SQL server or any other database, doing an ETL process to basically prepare the data for modeling, not in a sense of machine learning, but also just in sense of making data available. This also includes things like not every time you would have data readily available in a SQL server. So you'd have to, for problems like, let's say, customer churn, you'd have to create the data set with the lag. So anything that has to do with creating data set at a database level comes under this stage. Then you go to exploratory data analysis. You haven't started modeling yet. You are just exploring your data, checking distributions, checking multicollinearities to kind of create hypotheses that you would use in the data preparation stage. The next, which is a big one, data preparation. This includes things like if you have categorical features in your data set, you would do encodings. Simply one hot encoding is the simplest version. If you have missing values, you would train missing value imputers to kind of impute the missing values. Then you have a bunch of things like feature engineering, feature selection, polynomial features, removing multicollinearity. All that comes under data preparation. And once you have your data set ready, you have split it into train and test set, you get into model training and selection process, which is where you would train multiple estimators, you would log their metrics, you would log their hyperparameters, you would do hyperparameter tuning. Depending on the use case, you would sometimes do on-sampling, maybe wagging, boosting, or maybe even complex on-sampling like stacking. And then once at the end of the day, you have one model out of all the experiments here, one model which you want to use in production. The final stage is deployment and monitoring. And as you pass through this entire workflow, you realize you generate tons of metrics. And there are two forms of metrics, and which is one would be performance metrics of the estimator yourself, which would be things like accuracy, AUC, recall, MAE, mean square error. And then you also have a lot of metadata in terms of hyperparameters of models. So think about decision tree, where you would have parameters like max depth, you would have parameters like filters. So the point is, when you pass through the entire machine learning life cycle, there's a lot of metadata that you have to take care of if you want to keep a log of it. And that's where MLflow integration with PyCaret comes handy, because when you use PyCaret behind the scene, we are integrated with MLflow, and you will see that in demo. And we record all that metric and all the parameters and all the artifacts automatically without you doing anything explicitly. Okay, so PyCaret is an open source, low code machine learning library and end-to-end model management tool. And we call it end-to-end because we have this integration with MLflow that basically not only allow to log the metrics, but thanks to MLflow, you can now even serve the models using MLflow ecosystem. So this basically x-axis on this graph is the modeling stages. So you can see data preparation, training, selection, model evaluation. Y-axis is cumulative lines of code. And we have performed this simple experiment where we have written down a list of tasks that we need to do, read the data, perform some EDA, train multiple models, tune hyperparameters, and evaluate it through some metrics. And we have performed this experiment simultaneously using scikit-learn and PyCaret. This orange line here is scikit-learn, and the blue line here is PyCaret. And what you would see is by the time you finish your experiment, you have approximately written 170 lines of code to achieve the same thing that you would achieve in PyCaret using 20 lines of code. So it's a big impact for teams who want to keep it lightweight so that it's easy on maintenance. And also it's very powerful for citizen data scientists, which is not basically centralized data science team, but also people who are working in different functions like marketing, finance, HR. It comes really handy for them. So far, the use case supported in PyCaret is for supervised machine learning. We have classification support, both binary and multi-class. We have regression. For unsupervised, we have clustering, anomaly detection, association rule mining, and NLP. And we have a brand new module coming up soon, time series module, which is which is something I'm really excited about. Okay, so now we would see, I have 3 demos for today. And in all the demos, you would see the flow like we would train models, we would tune models, we would analyze the performance, and we will deploy it. And one of the demo is basically, I'm going to show you how you can even serve the models using MLflow. All right, let's get to the demo part. Let me just bring my notebook here. First demo. Do you guys see the notebook? Can somebody give me confirmation?
Can you zoom in a little bit more, Moez?
Sure. Okay, is that fine?
Yeah, that's good.
Okay, great. So this is the first demo, regression. Again, the notebook is already uploaded on the Git link. So to install PyCaret, you can just do pip install PyCaret. By default, the slim version of PyCaret doesn't include all the functionalities, but you have base functionality when you do that. And if you want to do a full version with this notation, you can install full version of PyCaret. For this demo, I'm using a regression dataset. This datasets module is part of PyCaret. So when you can basically, there are a couple of toy datasets uploaded on our GitHub. You can use it just for trying out. So this data set here is, we have the 6 patient attributes: age, sex, BMI, children, smoker, region, and this charges column, which is basically a continuous value. So it's a regression problem where all these 6 values are X variables. This is my Y, and I'm going to predict the charges based on these 6 variables. The first step in PyCaret, which kind of handles all the data preparation, is setup command. And the setup function, or the way you write it, is common across all the modules of PyCaret. So whether you are doing classification, regression, clustering, anomaly detection, NLP, this format of writing code stays same. So you don't actually have to learn differently for different modules. When you initiate this setup function from PyCaret regression, it would by default infer the data types of your features. And if you find them okay, in this case, age is numeric, sex is categorical, smoker categorical, region categorical. If you find okay, press enter. There's actually a way to override this. And if you read the documentation in setup function, you would figure out that if you want to override the data types in PyCaret, that there is a parameter in setup function that you can pass. Okay, all the pre-processing and all the data preparation is handled at this stage. So by default, when you execute setup, PyCaret would split the data set into train and test set. So you can see train set. So we had 1,300 records, which were split into train and test set. The other thing that PyCaret does by default is it would impute the missing values if there are any missing values in the data set. Even if you don't have missing values, it would create imputers in the transformation pipeline, so that when you have NAs in your production data coming in and you don't have control in front end, PyCaret would use those imputers to impute the missing value and then pass it to prediction, so that if you have null values coming in your production data set, your function should not fail. And then one-hot encoding. So in this case, we had a couple of categorical features. You cannot use them directly for modeling. So PyCaret, whether you ask it or not, it would do one-hot encoding default. Other than that, all the other pre-processing features such as normalization, transformation, scaling, feature extraction, feature engineering, PCA, combining rare levels, outliers removal, all that, you can just simply pass it with the flag like true and false. So it's not really hard to do that. It's a matter of just passing true. But that's up to you. If you want to do it, you can pass it here. All right. This is how you can access your transform train set and test set. So in this case, you can see age and BMI remain same, but because sex was a categorical feature, it was kind of dumbified, or I would say one-hot encoded. Same with the other features here. It's a table of ones and zeros. All right. So the first step. So now that we are done with the preparation of data, the first step we recommend in any workflow for PyCaret is this function called compare models. And what compare models does is it would basically train all the estimators available in the model library. So basically all the estimators means all the scikit-learn estimators, XGBoost, GetBoost, LightGBM, NGBoost, genetic programming, anything that is consistent with FitPredict API would work in PyCaret. And I think 99% of algorithms are compatible with that scikit-learn FitPredict style. So when you run compare models, what it's doing is behind the scene, it's training all the estimators available and doing a 10-fold cross-validation and returning you these metrics. So this is regression. So that's you get mean absolute error, mean squared error, RMSE. If it was a classification problem, you would get things like accuracy, AUC, recall, precision, kappa. And you would see this nice little table, and it would basically, based on the metric, whatever metric you define, by default, it's sorted to R squared. It would return you this best model and the metrics based on 10-fold cross-validation. Okay, so if I check the best, it's a gradient boosting regressor with all these hyperparameters, and these hyperparameters are just the default values of scikit-learn. And if I just check the type of best, it's basically a sklearn ensemble class, right? So you don't have to, even if you're using PyCaret to replace your boilerplate code, you don't have to rewrite your downstream processes, because what you get from here is basically scikit-learn model, right? You can call .predict out of it. You can do whatever you can do with scikit-learn class. While compare models is really good function to kind of have a baseline models ready based on default hyperparameters, the more granular model function we have is called create model. So when you do create model, it basically trains the specific model, and this DT is the ID of the model. And if you check the documentation, it will basically give you all the IDs and the model. So in case if you want to, let's say, train Bayesian Ridge, instead of DT, you would say BR, and now it would train Bayesian Ridge, right? If I show you, it's a Bayesian Ridge model. Okay. Behind the scene, when you call compare models, what we also do is use create model to create a loop and give you this output, right? But create model kind of give you more granular control. All right. With tune model function, you can tune the hyperparameter. So in this case, I have a decision tree, 10-fold cross-validated. Mean score is, let's say, $3,148 in mean absolute error. Now I would tune the hyperparameter using tune model function. And let me just remove it for a second. Let me just run this. So when you do this, this is going to tune the hyperparameters. And how does it get the hyperparameter? Behind the scene, we have defined dynamic grids. So based on the estimator you are using, it would use the dynamic grids and iterate over the random parameters to kind of tune the model. So in this case, just tuning randomly using scikit-learn random grid search, we have gone from $3,148 to $2,051 in mean absolute error. This would not always improve. Sometimes tuning may have a negative effect because at the end of the day, it's a random grid search. But this function also provides a couple of options. So instead of random grid search, if you want to use any Bayesian technique or TOPT from libraries like Optuna or Tune sklearn or even Ray, we have a parameter here called search library. And if I just do search library is equal to Optuna, and now behind the scene, PyCaret would use Optuna Bayesian search to tune the model. So you can see 2006, so even better. The problem is if you were to use these techniques outside of your baseline code, all these APIs are really different. Optuna, HyperOpt, TOPT, they are different, right? And what PyCaret is doing behind the scene, it's like a wrapper. It would use the same search space, but based on this parameter, it would just switch to a different library for doing hyperparameter tuning. Now, if I just see tune DT, in this case, I mean, previously when we used the random grid search, we can have a look at one of the parameter. Min sample split was 2. Based on Optuna Bayesian grid search, it happens to be 6. Okay, and you can see other parameters are now a little bit different too. We have a function called ensemble model, which basically would take your tune model, which is this one, and it would wrap it around bagging ensembler. So in this case, if you see, we started with the decision tree giving us $3,148 in mean absolute error, 10-fold cross-validation. We tuned it using Optuna. We get to $2,006. And now what I'm doing is I'm taking my tune model, passing it through an ensembler, which basically by default is bagging ensembler. And now I'm even a little bit better. Okay, and if I just show you what this is the same decision tree that we tuned, right? But now it's wrapped around bagging classifier, which basically means it would build the same decision tree. By default, I think we are using 100 estimators, but you can change that parameter if you want. In ensemble model, if you check the documentation, we are using, 10 estimators. If you want to change it, you can change it to 100, 200, whatever you want. We also have voting ensemble, which basically means I can now create 3 separate estimators. So you can see create model DT is decision tree. This is lasso regression. Excuse me. This is KNN. I'm just doing verbose false because I don't want it to flood my screen. And then I'm passing these 3 trained estimators into a blend model function as a list. And if I just run it, what it would do is it would train the 3 models separately and would pass it in a blender. Obviously, performance is very bad because I have randomly chosen these models. This is not how you would do it. You would choose your best models to be combined together. And if I just show you what is Blender, this is basically all these 3 models wrapped around a voting regressor. And again, if you check the type of Blender, this is scikit-learn, right? Similarly, there's another technique called stacking. It's different than voting. But again, if you check stacker, this is doing the same thing. It's taking your individual models and wrapping it around a stacking regressor with a meta model. By default, meta model is a linear regression, but you can change meta model by passing the parameter meta model. Okay, you can evaluate your models in PyCaret. So now that we have prepared the data using setup, we have trained a bunch of models, we have tuned, now we have our best model. Just pass your best model and evaluate model. And you would see a bunch of options here. This is hyperparameters of the best model. You can see the residuals plot for this model. You can check feature importance. You can check interactive residuals. So people coming in from our background kind of misses the typical QQ plot and the residuals plot that they are used to seeing in R. And we have kind of somebody from community has actually implemented that in Python. So now people transitioning in from R would feel like home in Python. Okay. We have also integrated with Sharply, Sharp package in Python, which is basically another way to look at the feature importance, not exactly feature importance, but this basically tells you what your model is learning. It's a little bit too complicated to talk about this in this 30-minute, but do check it out. It's very interesting way to interpret your models. Model predict is a function where you can use your trained estimator now on new data to generate inference. And in this case, I can see if you don't pass any data here, it would just do the holdout set inference, and so you can get metrics too. So remember, our best model here was doing 2,700. So this best model here is $2,702 in mean absolute error. But remember, this is a cross-validated metric that is calculated on this train set. What you want to do is look at the test set metric for this before you actually trust on this model and put in production for inference. So when you just do predict model best, you don't pass any data. Data is by default set to none. If you don't pass any data, PyCaret would assume that you want to check the inference on holdout set so you can see the metrics. So in this case, $23.86, not bad. It's a little bit off, $250. Normally, the difference between this metric and cross-validated, if it's huge, it would indicate overfitting. But if you just check the head of this data set, you would see we have the label column, which is our prediction attached into a data frame. What I would do is I would create the new data set. I would copy the same data. I would create data 2, and I would drop the charges column. I don't have a production data set for insurance, so I'm kind of mimicking by using the same data set. You finalize your model. What finalize means that, remember, when you initialize the setup, your data set is split into 2 parts, train and test, right? And all the cross-validation is happening on the train part. And then once you see the holdout scores and you're okay with it, only then you call the finalized model. And what does finalized model do is it will basically take your model and fit it on the entire data set, which is 1338. So far, it's only fitted on 936, right? But now, just before you're pushing your model in deployment, you don't want to leave your data on the table. So you would basically take all the data and just refit the same model. Same hyperparameters, same everything. You're just refitting when you finalize. Now that we have a final model, we can simply pass that final model with the data parameter, and now it would return you predictions. So in this case, you can see it's a human readable output, one hot encoding, and all the transformations is happening behind the scene. But when we return you the output, this is what you care about, right? You can save the model by save model. And when you save model, it's not just estimator, it's all these steps in the pipeline. So in this case, we haven't done any normalization, scaling, transformation, feature engineering. That's why there are few transformers that are there by default. So for example, simple imputer is by there for default. The last parameter here would be model. So this is model, right? But if you were to do normalization, transformation, or anything in the setup stage, you would basically have a long list of transformers in the pipeline, and they are automatically organized, which basically means all you care about is just calling the predict function from the pipeline. All the orchestration is happening internally. And again, you can load it from load model. And if you load it, this is that loaded pipeline. All you need to do is call the predict model of this pipeline to generate inference. You can deploy your model on AWS, Azure, GCP with this one-word deploy model function. So if I run this, it would basically take the entire pipeline and push it to this bucket. And now you have a separate Python process sitting, or R process sitting somewhere, where you would just load this pipeline from this bucket here in AWS and call your inference off this pipeline. Very quickly, I would show another demo, which is pretty similar, but this time I'll show you. So I have this data set here, air passengers data set. This is a time series data set. Unlike the last example, the order of rows in this data set is important. Although there is a new time series module coming in PyCaret, but today, if you want to handle time series data, you can do it using PyCaret's regression module. And that's what I'm going to show now. let's do some visualization. Let's just plot this data on line graph. I've created a moving average for 12 months just to see the trend of data. So you can see this is how it looks like. We have time period from 1949 to 60 here. We have this seasonality that we see in the blue line. This is actual numbers, and this red line is a moving average of actual numbers. So this time, what's different is you cannot directly consume dates in your machine learning models. What you have to do is extract the features out from dates. So things like month, year, a continuous sequence of number to capture the trend. So that's exactly what I have done in this part. So now after running this code, you see this is how my data set looks like. I have series, which is just a continuous sequence number, year, month, and passengers. And I've just dropped the date column. I'm now going to split my data set into train and test based on the year. I want to keep all the raws before 1916 to train, and last year, 12 points of 1960 as my test set. Here you go, 12. What's different this time is when you initiate this, this is exactly same as we have seen in previous example. But when you execute this, you have to basically tell PyCaret that fold strategy is time series, because the way you would do cross-validation for your time series data versus non-time series data is a little bit different. You cannot randomly shuffle that. So this indicator would tell PyCaret, okay, it's a time series data and I cannot do random shuffling. And I would just add one more thing here is log experiment is equal to true. Oops. And let's say experiment name is equal to air passengers. And this time it didn't ask for that confirmation because I have passed silent is equal to true. Imagine if you didn't have silent here, it would ask for this, right? And when you're running this code on terminal, command line, or in production, you don't want to have this confirmation box. So what you would do, you would explicitly define your data types here, like this one, numeric features. I've basically explicitly called PyCaret that this is numeric feature. And you can say silent true because you don't want to press enter in production. Same thing. I'll do the same function, compare models, sort by MAE. So now this is fitting 10-fold, fitting 3 folds time series cross-validation. Why 3? Because in our setup code, we have asked it to do fold is equal to 3. 10 would take a little bit more time than this. Okay, so now behind the scene, this is running, same thing. This is running a bunch of estimators and fitting 3 folds and giving you cross-validated metrics. And by the way, while this is complete, you can use the exact same thing on GPU as well. There is a flag called GPU, which is set to false. You can pass use underscore GPU is equal to true, and all the workload would fall on GPU if you have a compatible NVIDIA CUDA enabled GPU. Okay, let's see what's the best model. So this time you can see we have this model, which is least angle regression is our best model, but this is wrapped around a power transform regressor. And the reason for that is I have passed transform target is equal to true. And the reason I did that is because the mean of this data is not stationary. So I wanted to transform my target values. By default, PyCaret would use box-Cox transformation to transform the target values. And then when you call the inference of this model, it would inverse the transform values and return you the actual original scale, because that's what you care about. But behind the scene, it would handle that. Okay. Again, I'm going to do a prediction holdout 25. Not bad. I think the cross-validation is 22.3. Again, you can do evaluate to kind of learn the residuals or feature importance if it's available. You can see it has picked a bunch of seasonality here. Let me just quickly plot. So this is, you see red line is the prediction that the model has learned from data. The blue line is passengers. And if I just do a visual test, it looks okay. Towards the end, this section here is the test set. I've just created a backdrop for you to notice that. So it looks like a good fit to me. To generate the prediction, also for time series, instead of you don't have X variables that would come in and you would call predict, right? So what I do is I created a future data frame. My training data ends in 1960. I've created a data frame for next 5 years, which is nothing but just a same thing, right? 1961, 1, and continuous series. I would finalize my model and I would just call the predict function of it. Now I have future values for this data set. And if I just quickly show you on the plot, this is how it looks like. Again, not bad, I would say. But one thing to note here is we have done this log experiment is equal to true in our setup function, if you remember. Where is the setup function? There, log experiment 2, experiment name is equal to air passenger. So what happened behind the scene is if I initiate a MLflow server on my local host, you would see there would be an experiment here called air passengers. And in this air passengers, we have, let me zoom out. We have all the models that we trained using the compare model. So you have all the models here. And if you just open one model, let's say least angle regression, you would see date, timestamps, bunch of important information, but also all the hyperparameters of this model, all the metrics of this model. You would have artifacts. The grid that you see on the screen is logged as an HTML file. So if you want to connect your downstream systems with this, but also you would have this model here that you can serve right from here, right? Now, one more, I would skip demo 3 in the interest of time. What I would do is you can use actually, at this point, you cannot use the MLOps capability because I haven't, my backend URI is a file system. But I have an example here. This file here, which is also uploaded on GitHub, is I have created this Python script where I'm importing regression. I'm loading a same insurance data set. And now I'm setting my tracking URI, which is for setting it to ML runs. So by default, it would create a database, SQLite database. It would use that to record the metrics and artifacts. And I have this simple script where I've created create model in a loop. And what I want to show you is if I now open my command line, let's navigate to this and run this script, demo4.py. What it would do is it would now set the tracking URI and run this script for PyCaret. It would initialize the setup. It would create models, and notice that I have silent is equal to true here because this is a command line script. Okay, so it has started working. Let's give it a minute. Okay, and one thing different is notice that how I open my MLflow UI when in Notebook with this command here, MLflow UI, right? What is different when you set a tracking URI is you have to initiate your MLflow UI server with this command here, which kind of points it to a backend store URI. All right. Okay, it seems like it's done almost. Okay, and now I'm going to just copy this code here, and I would initiate my URI with the backend store. And when I do that, if I open my local host, oops. I have to kill my previous MLflow server. Activate PyCaret -dev, cd PyCaret. Just initiate the server. Okay. Now that I have it running on my local, Okay. So insurance demo 4, for some reason, it's not showing up here. I think I have conflicting MLflow servers running on my computer, but essentially, it would initiate another experiment, and this time around, you would be able to use the register model functionality of MLflow, which basically pushes your model as an API on your local. Let me just try last time, and if it doesn't work, we'll start taking questions.
Sometimes the demo gods go against us.
Yeah, totally. This is the time for that. Okay.
Wouldn't worry about
right.
it.
I think what happened just right now is because I have my other screen and I have a localhost 5000 MLflow running there, which I didn't end it, and because I'm running another localhost with the backend, I think it's conflicting. The only problem is I don't see the new experiment there. But in a normal world, this would work for you.
Or you can start the MLflow server with a different port, and then you wouldn't have a conflicting port. But I think you showed the gist of the idea.
Yeah. All right. Okay. Do we have questions?
Okay. Thanks a lot, Moez. I think that was a flawless demo, except for the conflicting ports. But I think you pretty much demonstrated how easy it is for PyCaret to be able to actually integrate the MLflow. And all you actually had to do for all of those experiments is just provide that experiment name. And when you do that, the code behind creates an MLflow experiments and then starts to run and tracks everything. Correct?
Right. That's correct.
Okay, so the integration is just by using the API to give the log experiment name, and that just automatically seamlessly creates the tracking experiments for you. Exactly. Brilliant, love it. Okay, question for you, Moez. Does PyCaret support embeddings for categorical features? If I have a categorical feature, how do I actually embed that?
At the moment, the only type of encoding you can do in PyCaret is one-hot encoding, but in our releases, we have planned to integrate things like weight of evidence and target encodings.
And are you still limited to use Python 3.6 for PyCaret, or are you going to be updating to 3.7 or 3.8?
I think it works fine with. I'm using 3.8.
Okay.
0.6, 0.7, 0.8.
And then early on, you actually showed the comparison of the number of lines of code you actually need with scikit-learn and then with PyCaret. Do you have some similar comparison, say, with AutoGluon?
No.
And does AutoGluon supported in your PyCaret?
I'm not sure.
Okay.
I believe AutoGluon is a AutoML library, right?
Yeah.
Okay.
It's a version of Gluon with a little AutoGluon. So what is the difference about doing time series in the future version with PyCaret? Does it actually run through more modules?
Yeah, so what I've shown you today using regression module is all the regression models, right? In future, for a separate time series model that we are going after, it would also include classical statistical methods like TBADS, ARIMA, SARIMA, vector autoregression, and it would also then include normal regression models. So our model zoo would be more comprehensive, and we would have some time series specific plotting functionalities like ACF, PACF plots, decomp plots, and stuff like that.
Yeah, fantastic job, Moez. A lot of people actually giving a lot of compliments. I think I don't see any more questions over here. I think there's definitely a lot of interest that people will be downloading your links and having a go at it. And the fact that it's okay. Here's how does PyCaret handle unbalanced data?
Good question. So there's a parameter in the setup. It's called fix_imbalance. When you set it to true, by default, PyCaret would use this mode. But there's another parameter in setup, which is imbalance type, where you can pass your own class if you want to do undersampling, oversampling, or even a hybrid. As long as your classes are compatible with IMB learn, which is the library for handling imbalance, we would use those transformers, just like you would use outside of PyCaret.
Okay, does PyCaret currently support or is planning to support distributed training with Spark or PySpark ML?
Yeah. I just put a poll yesterday on
yes,
my.
I saw that on PyCaret. I was the first one to say yes. Go ahead.
Asking this question, and so we are figuring out. So we have a very solid integration with Ray for our distributed need. And in fact, one of our core contributors is now working in Ray as well. So we have very solid. So initially we were thinking we would use either Dask or Ray or any Pythonic infrastructure, but now we see a greater need of having a library for Spark exclusively. So we are talking about that.
What's the future for PyCaret functions for NLP?
So at the moment, our NLP is very limited to topic modeling. So you have classical things like LDA, NNMFs, factorization. So only topic modeling, but we don't have a to be honest, we don't have a very strong roadmap for NLP, because I think NLP has taken its own journey in the last 1-2 years with this transformers. I think there's a lot of awesome community work being done exclusively on NLP. So it's not kind of our focus at the moment for PyCaret.
Okay, I think we'll take the last question before we head out to the next speaker. Thanks, Moez. You showed a great demo. Can you, if I was using an SQL backend server installed on the server, how would I actually use that with MLflow? I think I can answer that question, but you can confirm that more. So I think all you have to do when you're actually doing that is to provide the tracking URI to be to that particular backend server. And I think the experiment would actually take care of that, right?
Exactly. So I've just posted this. So if you notice on my Visual Studio demo 4, just before the setup function, I have passed this MLflow set tracking URI, and I've passed this for SQLite. You would replace this code with your tracking URI, and PyCaret is smart enough to kind of detect that.
Okay. Well, thanks a lot, Moez. We appreciate it. I think we've answered all the questions. In the interest of time, we will move on to our next speaker.
Sure. Thank you, everyone.
Thanks a lot, and continue with your great integrations. And send me the slides if you can, so I can upload it on LinkedIn. So send me the most latest one that you actually presented today. Thanks a lot, Moez.
All right.
Okay, moving on. Our next speaker is my pleasure to really introduce to you Geeta Chauhan. Geeta Chauhan is the lead PyTorch contributor for MLflow. She leads the partner engineering team at Facebook AI, and she has been quite instrumental and lead in contributing a lot of integrations with MLflow. She works very closely with our MLflow engineering team. And without any further ado, Geeta, please tell us all the integrations with PyTorch and MLflow, what happened in the past, what's currently, and what we are thinking of doing in the future. Take it away, Geeta.
Thanks a lot, Jules, for that lovely introduction. And Moez, thank you for your wonderful presentation. So let me share my screen. So as Jules mentioned, I lead the PyTorch partner engineering at Facebook. And today I'm going to talk to you about reproducible AI using PyTorch and MLflow. So this is the work that started last year. We did the phase 1 launch of it at the PyTorch Developers Day back in November. And now we are working on the next batch of new feature integrations. So we'll look at what are the challenges for reproducible AI. Then we will look at how MLflow and PyTorch as a combination solve this, and then we'll go into a few demos. So unlike traditional software, machine learning involves a very continuous iterative process where one is optimizing for a metric like accuracy. The quality of the results depends on the data and the tuning of the parameters. Experiment tracking, if you don't have a tool like MLflow, is quite difficult to do. You run into challenges like over time, your data changes, you face problems like model drift, and the performance of your model degrades. So you have to continuously monitor and upgrade your models. Additionally, if you don't bundle all the model artifacts along with the model itself, like the vocabulary files in the case of NLP models, they can get lost, especially if your teams are growing or people are leaving the company. Maybe all the code doesn't reside on GitHub or your internal source code repo, so it's very difficult to track and trace all of that. When you're deploying your models in production, you have to combine and compare many libraries together to get the optimal results, and can be quite challenging, especially due to the very large number of diverse deployment environments. Same thing when you're training, you have to mix and match so many libraries. So this continues to be a moving target and a big challenge that people have to solve. So luckily, with the integration of MLflow and PyTorch, many of these challenges can be addressed. So as you guys already know, MLflow has these great features for the model tracking, all your experiment tracking. You have the MLflow project where you can package all your code into a reproducible run. You have the model registry where you can store all your published models and any artifacts associated with it, and the MLflow models, which now provides options to deploy your models into the diverse serving environments. And we did integrations into all of these areas with PyTorch. This was part of the first launch that we did back in November. So we added the PyTorch auto logging support with the MLflow tracking. So here we use the PyTorch Lightning as the training loop, and we integrated auto logging with it. All the samples that we have provided for PyTorch have the MLflow project with it. So all you have to do is just call MLflow run, and you can get everything is parameterized and very easy to reproduce for your teams. In the model registry, we added support for saving the artifacts, including the ability to save and load Torch scripted models. So PyTorch supports both eager and Torch scripted models, and you can save those in the MLflow model registry. And lastly, we integrated the Torch serve as a MLflow deployment plugin. So you can train your models and then deploy them using this plugin seamlessly from the MLflow itself. Okay. So let's look at some of these features. So on the auto logging side, it is really very simple. All you have to do is import the MLflow PyTorch and call this one line to start your autologging mlflow.pytorch.autolog, and then you will have your trailing loop like before. So in this example, what you're seeing is a PyTorch Lightning training for an MNIST classifier. So you set up the model, you set up the data module for it, and you define the things like early stopping, checkpointing callbacks, and you can then do your model training and get the results. Okay, so auto logging will automatically log the relevant parameters for each of these scenarios. So if you're doing early stopping, etc., so all the parameters get logged. So the learning rate, things like model summary, optimizer name, min delta, best score, all these get logged. You also have the ability to control how often you want to do the logging. You can do it every n iterations instead of doing it at every iteration. And you can define your own custom user-defined metrics like F1 score or test accuracy. This is what the comparison of the experiment looks like in the MLflow UI. So this is one of the real great features that I love about MLflow. You can quickly, as you run your multiple experiments, you can select them and do the comparison and review what is the changes across the parameters, the metrics. You have all these plots, the scatter plot, contour plot, and parallel coordinates to give you the full detailed analysis. So what you see here is an example of a iterative pruning, and you're seeing the contour plot corresponding to it. For the save artifacts, we added support for saving the additional artifacts like, the vocabulary file. If you are deploying your models for production, you may have additional configuration files like your class mapping file. And in the case of TorchServe, you will also need, if your model requires any additional packages, then you can also bundle your requirements.txt and provide those additional extra files to go along with it. And for Torch scripting models, again, it is very easy to log. You just call the torch.jit.script, get the scripted version of the model, and then you call MLflow PyTorch.log model and pass the scripted model, and it will save it. So you don't have to do anything special. Both eager mode and Torch scripted mode are supported. And for those of you who are new to Torch scripting, it is basically a serialized and optimized version of a PyTorch model that runs in a Python free process. So you can run it with the C++ backend. That is how a lot of the production deployments happen inside Facebook. You can also run it with a Python backend, as in the case of TorchServe, where it will give you a lot more optimized, speed. We have seen speed ups of up to 4x for BERT models when using TorchScript versus the eager mode. So this is a big picture overview of TorchServe. It is the model serving solution that we jointly launched with AWS last April. It is for serving PyTorch models. It provides you all the default handlers for common ML tasks like image segmentation, text classification. You can write your own custom handlers. We give a very nice out-of-the-box model zoo to quickly get started. It has a robust management API, the inference API, and the metrics API. Supports dynamic auto batching, versioning, rollback support. You can log all the common metrics for performance tracking. It has integrations with many of the deployment solutions like SageMaker, Kubernetes, MLflow, and you can track all your metrics using Prometheus and Grafana. So this is the deployment plugin with MLflow. We provided both a command line interface as well as you can run it through the Python API. You can have a local instance of TorchServe or a remote instance of TorchServe, and it runs for both. So you just call this MLflow deployments create to deploy the model, and to do the predictions, you will call MLflow deployments predict and run your predictions on that. So this is when you're calling through the command line. And below that is the code for the actual, if you're calling it through the API. So in the case of API, you will get the deployment client and then call the create deployment and the plugin.predict to run your prediction. So some of the new features that we are currently working on, first one is support for Captum for model interpretability. So Captum is the model interpretability library for PyTorch, and it supports attribution algorithms for interpreting. You can do the interpretation of predict the outputs with respects to the input. You can do the prediction of the outputs with respect to any of the layers in your model, and the neurons with respects to the input. And out of the box, we provide many algorithms for gradient and perturbation-based approaches. And the picture that you see on the right-hand side, it is an example of a multimodal situation where you have both an image and a text. So these stripes of the zebra are what characterize the image as a zebra. And in the word, the sentence, what is on the picture, the is and the picture are more important, and they get highlighted in green. Okay. So these are the algorithms that are supported for Captum. You have the attribute model output with respect to the input features on the left-hand side, and with respect to the layers on the right-hand side. You may be familiar with many of these already, like the sharp method, deep lift, shapely, saliency, all these are supported. And the good news is that it is very easy to use. All these algorithms follow the same pattern. So all you have to do is import the, like call this from Captum attribute, import the relevant algorithm, and then pass your model to it, give it a input and a baseline, and then call the attribute algo.attribute and get the output results. So in the new features integration, we are adding support for Captum for model interpretability during your experiment when you're training your models. So this is already, examples for this are already available in the core MLflow repo. We have added support for Axe and PyTorch for hyperparameter optimization. And we are in the works for the model signature support in the MLflow TorchServe plugin, and for the model interpretability on the TorchServe side, that is also in the works. So the code example that you see on the right-hand side at the top is the code for the Captum. As I mentioned, you just call your integrated gradient and pass the model to it, and then you pass the inputs and get the results, and then you can do the visualizations for it. And you can log all of this at present as artifacts in MLflow. And in future versions, we will add support for visualizations inside MLflow UI itself. And at the bottom, you are seeing some example code for the model signature. So with this, we will use the MLflow model signature feature, and we are integrating that in the TorchServe side. So if you have saved the signature of your models, all the inputs and outputs, then we can do a validation of the inputs with respect to the model signature and throw errors in case the inputs do not match the signature that was specified for the model. And in the bottom left side is the visualization that for the Captum results. Okay. So for the model experimentation and the Axe and PyTorch, I just wanted to give you a view of how we use this adaptive experimentation using Axe and PyTorch inside Facebook. So what you see here is an example of how we use it for our newsfeed and ranking of the content across a variety of signals. So we combine it using a collection of rules, like from a configuration policy, and it is dynamic. So we mix the results from both the offline simulations as well as the A/B testing, and then we get the actual results with the multitask model, and we can optimize and using the Axe and PyTorch for the best parameters and use those and get the next best experiment candidates and iterate on that. Okay. So now you can use the same for hyperparameter optimization using Axe and PyTorch with the MLflow. So you set up the Axe client, then you create the experiment, you set up all the parameters that you want to optimize on. So here we are looking at the weight decay and the momentum, and then we run the actual trials and we log the best parameters in the end. So let me dive into a few demos now. So are you able to see my screen? So yep. This here is my server running in the cloud, and I just ran an iteration for the Axe experimentation. And while it is running, maybe I can just show you what the output looks like. So at the end, you will see all the trials. So these are the acts trials. You can do the comparison across the trials. So the momentum, weight decay, these are the ones that we are finding the best parameters for. And what you will notice is we are using this parent and child scoping feature of MLflow. So the main process that launched it as the parent ID, and all the trials get logged as the child. And if you go and see the results on the parent, you will see that we have logged the optimum learning rate, the optimum momentum, and the weight decay out of all the trials that were run. And you can get all the details about your model summary, your data, etc. Like, okay. The other demo I wanted to show you is I recorded it just so that things work fine in the demo. So this is for the Captum integration. So for this one, we are using a MLflow server hosted on AWS. So we are setting the MLflow tracking URI and the MLflow experiment environment variables, and then we call the MLflow run with the relevant parameters, in this case, the max epoch, and we just launch that. And you will be able to see the actual runs. Why don't I show this to you here? So this is the Captum run, and it is saving all the artifacts. So in this particular case, all these feature importance with respect to neuron, the feature importance, neuron importance, all these are saved as images. And in the future version, we are discussing with the MLflow team on how we can have this as a better feature in the MLflow experiment UI itself. Okay. So if you want to find out more about Captum, you should go to the captum.ai tutorials, and we have a great set of tutorials for a variety of examples, including visual question and answering, recommender models, BERT models. So please take a look at that. For the Axe and PyTorch, go to axe.dev. This is where all the hyperparameter optimization details are available. And let me walk you through the upcoming feature that we are going to integrate soon. This is for the Captum insights for model serving. So this will come in the MLflow TorchServe repo. So what you see here is again a BERT example, and we are using Captum for the integrated gradients. We are doing the computation. So this here is the actual model for it. We've set up the wrapper for it. The tokenizer is specified. And this is the scoring function that we are using. And this is where the Captum attribution is getting called. And then you can visualize it. So we have given a Jupyter notebook for you to generate these nice visualizations. You can see that in the Jupyter notebook. And then when you integrate it with TorchServe, this is where we are creating the TorchServe deployment. And then we are going to have a new CLI for the MLflow deployments called explain. So similar to predict will be for calling the inference, and explain is for getting the interpretability results. And when you call that, then you will get the output of the model interpretability for your prediction. And again, you can visualize the output of that particular JSON using a Jupyter notebook. So all these demos for the main PyTorch demos are available under MLflow examples PyTorch. So you will see the AX hyperparameter optimization example, the Captum one that we just walked through, and the iterative pruning, which is also using the hyperparameter optimization. And let's look at some of the code in detail. So this is the AX hyperparameter optimization example. So we have set up the AX client, then we pass all the parameters that we want to optimize for the learning rate, weight decay, and momentum. And we are calling the trials in the loop, and then we log the best parameters. So these are the best parameters that you saw. In the iterative pruning, again, we are using AX and PyTorch for this, and we are doing optimization for reducing the overall size of the model, pruning it to have a smaller compressed footprint of the model when you deploy your model for production. So here again, we have some parameters that we are optimizing on, and we are calling the PyTorch pruning library and doing the iterative pruning for that. So this is the iterative prune. We are pruning the model and saving it. And the Captum, so this is for the Titanic database example. It's a simple neural network. We have all the training and the test features. So it is using the PyTorch Lightning training loop. And then we have the visualization piece for it. This is the actual training. And this is where we are doing the Captum feature conductance and the layer conductance to get the interpret and the neuron conductance, the three things that we had saved. Okay, so now this is the complete workflow that you will have for MLOps using MLflow plus PyTorch. So as a data scientist, you will build your PyTorch models for autologging and all. You will use the PyTorch Lightning training loop. You can train the model either on a single device, on a single machine, your CPU or GPU, or you can do distributed training, which is just a matter of passing the extra parameters needed for your MLflow Lightning training run. And then when you're ready with your experiments, you will optimize the model and torch script it. And you will log the torch scripted model along with your other previous experiment runs into the model registry. And from there, you will use the MLflow TorchServe plugin to deploy the models, and then you can use the full features on the TorchServe side for your model management, all the inference prediction, the explainability, all the metrics and everything from the TorchServe main interfaces itself. And these here are the next set of features that we are currently working on. So the Jupyter notebook that I showed you for the Captum interpretability for inference in MLflow TorchServe. So that PR is under review and should get integrated soon. We are discussing with the MLflow team on how to do the custom insights visualization in the MLflow UI itself. And we are also working on the new PyTorch profiler, which was launched with the 1.8.1 release. It has a new TensorBoard, PyTorch TensorBoard profiler plugin that you can visualize from TensorBoard. And we are working with Jules and teams to figure out how we can integrate this into the MLflow UI. And we will continue to add more examples for you guys to quickly get started on a variety of use cases that would be relevant for you in MLflow and PyTorch. So, please reach out to us on GitHub, engage with us on Discuss and Slack channels. If there are any specific features that you would like to see, please open up GitHub issues around that and give us feedback. So here are some references for you. Please check out the PyTorch MLflow Autolog blog. We will be publishing a new series of blogs in this coming this month and next month. So please look out for those on the PyTorch Medium channel. You have the MLflow TorchServe deployment plugin, all the examples, the links for that. And I quickly walked you through the Captum.ai, Axe, and Botorch sites. And one more thing I wanted to mention is that we have been working with Archive and to see how we can make model research reproducibility an important item. So what we have done is we worked with Archive and integrated all the code in the Archive site itself. So if a paper is published with code, you can now see the corresponding code for it on the Archive site itself. So we are investing heavily on how to promote reproducibility in the research community. So this is one of the key efforts that we did last year. And we are continuing to work with the major research conferences like NeurIPS, etc., to have a reproducibility checklist. So I have added some links for those for the reproducibility checklist for you guys to think about when you are building new models, how to make it easier for other people to adopt and reproduce the results. So please use this in conjunction with MLflow to get great results across your teams. And this is my contact information in case you guys would like to connect with me. So I'll open it up for questions now.
All right, thank you, Geeta. Thanks, wonderful for us to giving us both the past, the present, and the future integration with PyTorch. We actually come a long way and has just been an incredible extension of how PyTorch actually with MLflow extends the ability for machine learning and data scientists to actually use those in conjunction. And I was quite happy to see that you could actually reproduce all the examples that were uploaded in MLflow as an MLflow project. So you can just run MLflow run project and you actually get all the experiments. So thanks a lot for that wonderful tour of the MLflow integrations with PyTorch and what are some of the exciting ones which are coming up. We're really looking forward to have the profiler and the TensorBoard as part of the integration with MLflow UI and the ones that you are currently working on to get the PR merged in. Couple of questions. I think this is for both of, I don't know if Moez is there, I think is gone, but question is it possible to train PyTorch models in PyCaret? The PyCaret guy is not here, so I can't really answer for that, but I'll try to get an answer for that and put it on the Slack channel. Let me see, do I actually have another questions over here on Q&A? Seems like I don't have anything on LinkedIn. Let me see on the YouTube. If you have any questions over there. A lot of compliments, great demo, a lot of work. Yeah, we'll be posting out, we'll be including the link presentation and all that in the YouTube description. So once we actually get the PDFs and all that, we will update that. No, I don't see any more questions. So with that, I think we can probably conclude this presentation. Thanks a lot, Geetha. Thanks a lot, Moez, in his absence. You guys actually showed a great way to show that how MLflow allows you to extend with the larger ML ecosystem, and this is really a proof that MLflow is very adaptable in terms of integrating with a large ecosystem. So thanks a lot, Geetha, and thanks a lot, Moez, who has left. I think he had another meeting to attend to. And if you want to see, as Geetha pointed out, if you actually want to see more integration from the PyTorch side, load those issues on the MLflow, and I meet with Geetha on weekly basis to make sure that we hear to the community what they actually want. So if you want to see more of integrations with other aspects of PyTorch, let us know.
Thanks so much, Jules. And I'll say another thanks to Geetha and Moez for these awesome presentations. And so the video recording is available up on YouTube now, and I posted that link in the LinkedIn and the Zoom chat. So I'll also update the description there with all of the resource links in the slides when I get them. So thanks everyone for joining us, and I hope you have a great rest of your day. Take care.
And thanks a lot, and wherever you are, stay healthy.
Thanks. Bye-bye.